Good afternoon. Thank you very much for the invitation. It is great pleasure and honor for me to be with you today, especially here in such a wonderful place, American Polish Cultural Center. And above all, because the hero of today's meeting is the great Polish astronomer and scientist Nicolaus Copernicus. The title of my short talk is De Revolutionibus Orbitum, the scientific revolution. The first part is written in Latin and it is referred to the title of the famous book of Copernicus. In English, it's on the revolution of the heavenly spheres. The scientific revolution, or the Copernican revolution, was a revolution in ideas. That's a very important thing to be conscious about. And a significant revolution that changed man's concept of the universe also. We can see Copernicus. It's a famous painting by Mikołaj. Actually, you can see it also on this poster here. I see poster number 15. The title of this painting is Astronomer Copernicus, A Conversation with God. It was painted by Jan Matejko in 1873. We see Copernicus here on a balcony, probably in his observatory near the cathedral in Frombork. I had the pleasure to be there, but not exactly at the time when Copernicus was alive. And Copernicus is surrounded by various astronomical instruments. And we will talk about these instruments later. These instruments and more details we can find on poster number 13, I see. The reason for painting this picture was the 40th anniversary of the astronomer's birth. So that's why we can see the date here. It's 1873. And we are celebrating now 550th anniversary, of Copernicus' birth. Formally, it's 551st, because it's 2024. Here is such kind of a short timeline. I am covering, of course, whole path of life of Nicolaus Copernicus, but I selected, from my point of view, of course, the most important dates in the life of Copernicus. So let us look at some important dates. First of all, we need to know that Copernicus was not only an astronomer. His achievements include significant contributions, especially in economics. He developed and introduced the quantity theory of money and the concept of inflation, which actually we are facing it very much in our life, inflation. So he was born on February 19th, 1473. Let me enlarge maybe this part here. So he was born in Toruń. Toruń is one of the oldest cities in Poland, located in the north-central Poland, inscribed by the UNESCO World Heritage List. And here we have some pictures. I am glad, of course, you can see these pictures on the posters presented on this exhibition. So I included also in my presentation. Then we will skip now, and when he was 18 years old, so we are talking about 1491, he moved to Krakow. Actually, I am from Krakow, and I really love it that Copernicus was there 4 years, and he studied in Krakow mathematics and astronomy mainly. The times of his studies in Krakow coincides with the heyday of so-called Krakow School of Astronomy and Mathematics. Many times, we know what Copernicus said about Krakow and especially about Torun. He said that Torun gave birth to me. Krakow shaped my thinking. So I am proud of it. At that time, of course, the name of the university was formerly University of Krakow, but now it's a Jagiellonian University. Then, as we see, in 1946, he moved to Italy and he started to study at University of Bologna, and he spent it long, I mean, five years, 96 up to 1501. Copernicus canonical law. He met there the famous astronomer Domenico Maria Novara and became his assistant, by the way. Then, after so many years, he moved to University of and studied there medicine, another 2 years. So now we are at the year of 1503. So Copernicus is 30 years old. Look, he was born in 1473. Now we are at the year of 1503 with a degree of PhD. He's coming back to Poland. So his education, he started education at the age of 18, let's say. We are talking about the level of the university education. So it took him 12 years. It's quite long, even for from the perspective of a modern time. Eventually, I am skipping here about, it looks 10 years of his activity between the year of 1503 and 1514, but this is the most important period of his life, 1514, 1532, when he completed the Revolutionibus Orbitum Celestium. He moved to Fromborg in 1510, and he spent the rest of his life in Fromborg. Okay, so this is actually the map of Poland in the times of Nicolaus Copernicus. On the left side we can see Poland and Lithuania in 1526. And the period of Copernicus' life fell on the reign of the Jagiellonian dynasty. King Casimir Andrew Jagiellonian and King Zygmunt the First Old, I mean the Zygmunt I First the Old, were two kings during his lifetime period. And this time is called the Golden Age of Poland. It was a time of a great power for Poland and internal peace. Poland and Lithuania, Grand Duchy of Lithuania, were very much tied politically, also culturally. So that's why it was just after the death of Copernicus, we became a Polish-Lithuanian Commonwealth, and it covered almost 1 million kilometers. As we can see, we were a country, a Commonwealth from Baltic Sea down to Black Sea. So pretty good time. Okay, let's go back now to the times of Ptolemy. So I'm sorry, but I am just jumping to the 2nd century Anno Domini, but I have some idea why. because we need to understand, in fact, why Copernicus stopped the sun and moved the Earth. So, the Almagest is the mathematical and astronomical treatise, in fact, on the trajectories of planets. An apparent motion of a stars as observed from stationary Earth. And this is exactly what we observe. When we have an instrument which is located in some surface of the Earth, we observe exactly what is described in Almagest. We don't feel the movement of Earth. So the picture of the cosmos and the trajectories of planets are kind of complicated. First of all, on the left side we see this model, which in fact was a dominant scientific model of the solar system for about more than 1,400 years. Moreover, Ptolemaic geocentric model of the universe was quite accurate. That's the very important thing. People were not just believing in something. We were able to collect data, and based on the model, we were able to predict the trajectories of the movement of planets. So it was a time of, let's say in this way, that the planetary retrograde and their paths were calculated within 1% of their observed position. So the model was really amazing. The model, of course, geocentric model assumed that the Earth is in the center of the universe. Then we have a moon, then we have Mercury, then we have a sun. No, we have before sun Venus, then Sun, then Mars, Jupiter, and Saturn. So it was the order. Now from the perspective of the observer, which is on the Earth, this is the trajectory of a planet. So we see it's kind of complicated. This trajectory is this black curve. We see here in the description of this trajectory, which ancient Greek mathematicians developed, we see two circles. The small circle, we call it epicycle, and the center of the circle is rotating around the big circle, and we call it center of deferent, deferent. Ptolemy wanted to improve this model, and he added something we call equant, which is this center moved toward the edge of the big circle. So the main features of the Ptolemy model are equant, epicycle, and deferent. What Copernicus wanted to do, he wanted to remove equant, as well as he wanted to remove epicycles, and basically he knew that it's possible only when he will, let's call it, move the Earth. That's why he moved the Earth. But we can ask the question, how it's possible that with these assumptions, when the Earth is the center of the universe, we really, this model could be such accurate within 1% of the observed trajectories of planets. So this lies actually in the Fourier analysis. It's it's just a little bit, let's call it advanced mathematics. It turns out that any smooth curve can be approximated to any accuracy given a sufficient number of epicycles. So practically speaking, if we could consider infinitely many epicycles, then practically speaking, the Ptolemy model, geocentric, we could perfect. But of course, it's impossible. Very not practical. So, what Copernicus did? Before we will say that, let us see the action. So on the left-hand side, we see the movement of the planet. Actually, this is the movement of Earth, and above the Earth is Mars. So please see what we see, how it can be seen from the perspective of heliocentric model. This is kind of a simple. We have a circular paths of the movement of the planets. For simplicity, this animation assumes that the orbital period of Mars is 2 years, not exactly 1.88 years, just for simplicity. And on the right-hand side, we have the Ptolemaic system, so geocentric model. So the Earth now is in the center. The Sun is moving around the Earth, as well as Mars. And we see that the curve, the trajectory of the Mars from this perspective is kind of complicated. And by the way, this is what we are collecting when we are collecting data. We see it from the perspective of the Earth, exactly this trajectory, the red one. But because we know that the Earth is moving around the Sun, then we can transform such complicated trajectory into the very simple one. It means circular. So the revolutionibus orbitum celestium. So the major features of Copernican theory are the following. First of all, the center of the universe is near the Sun. This is the first thing what Copernicus assumed. Heavenly motions are uniform, eternal, and circular, or compounded of several epicycles. It can be a surprise for you that still Copernicus used epicycles, because his main idea was to move, to clean epicycles from the description of the universe. But the problem is that planets actually are not moving really on a regular circles, but on the curves which are elliptical curves, so ellipses. And this actually was the main problem in the measurements which Copernicus was performing. His accuracy actually was worse than the accuracy achieved by Ptolemy. His accuracy was like 3% compared to 1% which we could achieve using geocentric model. So it was not an easy task for Copernicus to encourage the scientific society to believe in his idea. Another feature of his theory is that around the Sun, in order, are Mercury, Venus, of course Earth, Moon, Mars, Jupiter, Saturn, and the fixed stars above. This is amazing that he considered that the Earth has 3 motions: rotation, annual revolution, and annual lifting of the axis. That's why we have seasons, different seasons. Retrograde motion of the planets is explained by the Earth's motion. That's the main 5 features of his theory. So, like I said, Copernicus was, this is by the way from his book, this model when the sun is in the center of the universe and the planets and the fixed stars are around the sun. This is actually the first page of the first edition of the Revolutionibus. It was actually published in Nuremberg in 1573, just 2 months before the death of Copernicus. These are Copernicus astronomical instruments. Excuse me. So he used only, as you see, this was the time when telescope was not yet developed. So Copernicus used only solar quadrant, triquantrum, and astrolabium. Actually, solar quadrant it was instrument used to measure the height of the sun above the horizon. Triquantrum also measured the angles. It was used to determine altitudes of heavenly bodies. And how it, in details, how the description, how this instrument works, are actually presented on poster number 13. So here. And also astrolabium. Astrolabium was kind of like complicated astronomical instrument. Basically, astrolabium modeled the celestial sphere, and it was used to determine equatorial and elliptic coordinates. Here we can see nice animation which illustrates the simplicity of the heliocentric model and the complexity of a geocentric model. So on the left-hand side, we have a heliocentric model, and we are kind of familiar with it. For us, it's natural. But geocentric model, when we see the trajectories of planets, are kind of like complicated. What is amazing is that ancient Greek mathematicians could describe it with such high accuracy of 1%. Now, of course, the successors of Nicolaus Copernicus found out that, of course, his model is much better. Although Copernicus did not prove his theory, his idea initiated a real scientific revolution, the path of which was followed by Copernicus' successors, especially Galileo, Kepler, and Newton. Copernicus' ideas pushed the study of the universe to the new directions. Thank you very much.